Okay, we should start. A word of caution before this talk. This will be a boring talk, but it will save you money. I highly believe that this is a topic that we should start talking about, and the sooner we start talking, the more money you will save. So treat it as a visit to the dentist. No one likes to do it, but you should do a checkup twice a year, and that's all. Basically, the inspiration for this talk was a problem that I'm seeing on more and more architectural meetings all over basically our industry. We are talking about moving to the cloud, using the cloud, but the main problem that we are missing in all those conversations is the lack of talking about money. And let's not kid ourselves, money is a huge factor in talking about any cloud solution. In this case, we will be talking about Azure, but the principles apply to any cloud provider. The reason why we are not talking about money is that although we have the cloud for a couple of years now, we constantly have the on-prem mindset. On-prem, we didn't talk about money. We talked about specs and so on, and the machines basically magically appeared in the data center and we were able to run our application. So if we should talk about an application, let's tell about which application we'll be talking. So let's talk about architecture. A simple one, basically. We'll have a client that will be communicating with our application. Let's assume for simplicity that it will be a web application. So it will be talking to probably an IaaS server. This IaaS server will be talking to a database. Since, again, we are talking about Microsoft technologies, we'll be talking to probably an SQL server. And this is an awesome architecture, basically approved. Most systems architecture can be simplified to this, and some actually don't need any simplification. They just look this way. So the question is, so how do we put this system that, let's assume, is running on-prem and design it to be run in the cloud? Well, the simplest case would be to put it into a VM. Nothing simpler. We basically take all of the code and just have a different remote desktop connection to not on-prem, but to a cloud environment. Okay, so since we are talking about money, let's see what is the minimum that we have to pay in Azure for our VM. It's more or less 1 cent for an hour. Since we want to have a budget of $1 a day, it boils down to 24 cents. Awesome. Basically, we are on track. But since we want to pick the proper one, we just don't want to take the cheapest one, we should look at the whole spectrum. So let's look at the maximum we will be paying for a VM. It's about $27 an hour, which rounds up to $640 a day. And this is a bit way over our budget. Okay, so now we have the minimum and we have the maximum. But if we now need to pick, we need to know how many steps in between we actually have. If there are only 2, we don't have that much of a choice. If we have many, we have to know how much. So how much types of VMs are there actually in Azure? About 28 types. Each type is designed for really specific usage, and each type has subtypes, basically. So there is a lot to choose from. So I could iterate through all of them and say if it fits, but it doesn't make that much sense. Let's create some technical specification that will narrow the solution a bit. Let's say that we want from 4 to 8 CPUs, a modest server, and from 8 to 32 gigabytes of RAM. Sounds more or less okay. We are happy with it. Okay, so now let's look how our minimums and maximums look with this specification. Now the minimum jumped to about 16 cents an hour, which boils down to just below $4 a day, which is a problem. But the maximum goes from $0.50 an hour to almost $11 a day. So yeah, we are way over budget. Now we could basically end and say, sorry, it can't be done, but there is a way. There's always a way. One of the ways we can lower cost in Azure and AWS and Google, basically every cloud provider offers this option, is to reserve VMs. The idea is that we call Microsoft and say, hey guys, we'll be using such and such VMs for the next 1, 2, or 3 years. And then they say, that's awesome, we'll give you a discount. And we say, yeah, but we have to pay up front, so how big of a discount will you give me? We are a price-cautious consumer, so we want to know how much. 5, 10, something like this. And actually, the discount is quite significant. It's up to 72% from the price. You pay up front, and then each time you actually use a VM, the price is automatically lowered. Of course, this discount varies between different types of VM and different versions of VMs. So let's look how it would affect our specification. Our minimum used to be 16 cents an hour. If we use reserved VMs, we'll go down to just 6 cents an hour. So quite a significant loss. That boils down to just below $1.50 a day. It's way over budget, but in terms of IT projects, it's only 50% over budget, so we can call it a success, I would say. The maximum was more or less $0.50 an hour. Now it's 16 cents. It boils down from $11 to just below $4. So it's a quite interesting and quite good way to save money. We are happy. We are a bit over budget, $1.50, but we could call it a day and go home. But there is a problem with this. VMs, especially VMs in the cloud, are like Wile E. Coyote. They fail all the time. And actually, it's not a case of Azure or any other provider. Basically, every cloud provider says to us up front, sorry, embrace failure. We will give you a lot of machines, but they will fail. Prepare for it. This is a situation that we didn't have on-prem. On-prem, basically, the machine was up. There was a special guy maintaining it, and so on, so on. But in the cloud, we need 2 machines, at least. This means that our bill goes way up to basically way above $2 a day. So we are quite significantly over budget. The maximum value to about 8 hours a day. That creates a problem. But there is a different way. When we are thinking about the cloud, about on-prem systems, we got used to preparing VMs that look like this. That we would take a snapshot of the specs and send to our friend and say, yeah, my VM has so many cores and RAM and so on, so on, so on. But this mindset is one of the problems that I'm seeing when people start thinking about cloud. Take the same mindset and apply it to the cloud. But since machines fail, in our case, it will be a 4-core, 8 GB RAM machine. Doesn't make any sense. Let's take an example. Our machine will be a F4 version 2. It would cost, as I said, about 6 cents an hour, and it would boil down to the cost of just $1.50 a day. But if we change our mindset and think in a bit different way, basically we need a lot of processing power. Let's not think about beefy machines, beefy cows. Let's think about basically smaller ones, but a lot more of them. Let's take a B1S machine, a really small machine, 1 CPU, 1 gigabyte of RAM, nothing to be proud of. But this machine is quite interesting. The B stands for burstable. So this machine can actually, for some period of time, go on a way higher specification, use more RAM and more CPU, for example, for application start, which is quite nice. And we are not paying for it extra. If we take this machine, it costs about half a cent an hour. We used to be paying 6 cents an hour. We can have 12 of them, which is quite a lot. 12 CPU, 12 gigabyte of RAM. Going cheaper, going more commodity hardware in the cloud pays up. We'll be saving a lot of money. But let's be more modest. Let's use 8 machines. And our bill will be about 96 cents a day. Awesome, basically. We can call it a day. Not exactly, because there is one additional problem. We are trying to do this. We are trying to run our program with nine machines and trying to end pregnancy in 1 month. It won't scale. But saying it won't scale is a bit over the top. Let's say what won't scale. Let's pinpoint each problem, each module, and say what will be the problem. First, SQL Server. How to host an SQL Server or a database in the cloud. Actually, you have multiple options, as always. First, the simplest is a managed instance. Basically, we'll be going through each offering from the most like on-prem to the most cloudy one. And ideal with managed instance is quite simple. We make a backup on prod, we transfer the backup to the cloud, do a restore, and basically it works. On the plus, additional part is that the machine is managed by someone else. We just say what specs we want, and it works. Awesome. So, since we are talking about money, let's look at the prices. First, the specs. The minimum values are 8 CPUs and 56 gigabytes of RAM. That creates a problem, since it will be over our cost, at about $1 an hour. Is it much? I was expecting a way bigger price tag. It's a VM managed by someone else, almost 60 gigabytes of RAM, 8 CPUs with a SQL Server license. Quite nice. Is it too much? It's up to you to decide. For us, for this current problem, it's a bit too much. So let's go more cloud ready. Next offering is Elastic Pool Single Database. The idea behind this is that we are basically hosting a server, and we can host multiple databases on this server. Those databases will be sharing resources between each other. So when one is in the peak and the rest is not using those resources, we are not wasting money. Sounds okay. And as additional cost, we can limit the number of resources each database can use. So one won't starve all the rest. Awesome solution for hosting multiple small projects, websites, blogs, e-commerce, and so on, so on. So what will be the cost? The minimum actually is 1 CPU and 4 gigabytes of RAM, which is more in the ballpark of our price range. The price, 25 cents an hour. Again, it's way above our budget, but those numbers can be shared between multiple resources. If we have the use case, it's a quite nice price-cautious solution. But let's find something better. Azure SQL database. And by now you can be a bit annoyed with the naming convention. it could be better, but basically what we have here. Azure SQL Database has a pricing model based on DTUs. What are DTUs? The idea behind DTUs is that let's abstract the CPUs, the RAM and disk in some abstract units. Those units are based in a way that if we have one DTU and we buy twice as more DTUs, we will get twice as much performance, which for developers sounds quite awesome. I don't have to think about bottlenecks, RAM, CPU, and so on and so on. Basically, incrementing one single number and everything is taken care of. Okay, so the minimum DTU is 5. Not that much, but we are also not paying that much for it. Below 1 cent an hour. So about 16 cents a day. Way in the ballpark of our price range. But there is a catch. The maximum size of a database in this pricing tier is about 2 gigabytes. And this is the maximum number for all database files. So the temp file, the log file, and the main MDF file. Is 2 gigabytes a lot? I saw a lot of cases where it was more than enough. But for our solution, let's assume that we need something better. The next pricing tier is a standard tier. Here, we enter the 2 cents an hour price range, which is not that crazy. This boils down to just below half a dollar a day. And in this, we get 10 DTUs, so we are twice as performant. And we get the limit of 250 gigabytes for our database, which in most cases is more than enough. If we actually have a database that is way bigger than 250 gigabytes, then we'll probably need a different solution. And we probably have more money since the system is generating a lot of data. And I'm assuming making money. Okay, so is it enough? We managed to put our database and host it in Azure. It does not make any sense what we are doing. What we are trying to do here now is taking a solution that was developed in the 70s and to shove it into an environment that's main design principles are completely different. SQL databases run beautifully on very strong, big machines. And cloud is all about commodity hardware. So a lot of really weak machines. This means we have to go back and put our head into the cloud. If we are talking about cloud design databases and about Azure, yes, you can bet yourselves now we'll be talking about Cosmos. And one important thing to clarify about Cosmos. Cosmos is not better than a relational database. Cosmos is actually a Mongo database. It's actually an object database. It has way fewer features. It's less mature and so on, but it has different sets of capabilities. It's designed for the cloud. We are giving away some features, but hopefully we'll get something in return. For example, geo redundancy. So let's talk about Cosmos prices. And here is where it gets a bit complicated. Why? First, we pay for storage, which is quite cheap, 21 gigabytes a month. So this brings us to about 1/8 of a cent a day, which is not that expensive. Next, we pay for air use a second. Air use are resource units a second, and we'll go a bit deeper into what they mean, how they are used, calculated, and so on in the next slide. But for now, remember that you can buy them in chunks of 100s. And they are quite cheap, 1/8 of a cent per hour, which boils down to about 20 cents a day. But there is a catch. There is a minimum value of RUs that you actually have to have, which is 400 RUs. This increases our price to about 80 cents a day. Again, not that significant values, but we are getting way up in our pricing. So what is our RU? It's complicated, but Microsoft in its documentation tries to explain that it's a single get operation by ID for 1 kilobyte document. And what is also important is that RUs are being counted in chunks of 1 second. So you have to be under the specific value in this specific second, and each second they replenish. But if it was so simple, it would be quite awesome. But the problem starts when you start doing selects, or you start doing where operations and so on. Because if your operation is touching, let's say, 10 documents, each being the size of 1 kilobyte, and returning one document of size 1 kilobyte, you will pay 11 RUs. If you are inserting one document of size 2 kilobytes and updating an index, you will pay for each additional operation, for triggers, for scans, seeks, and so on and so on. There is no upfront way of actually counting how many RUs will be actually needed. This makes using them complicated. The more complicated case is that you have to provision RUs. If you buy 1,000 RUs, and in 1 second your query or queries will want to use 1,500, you will get an error. So the problem with RUs is that they have to be provisioned for peak usages. But there is a way to optimize it. RUs can actually be changed dynamically with an API. So if we are expecting a peak usage, we can increase RUs quite significantly and then lower it down. But again, we have to provision up front. So is there a better way? Is there a way to actually pay for what we use, not to think what we will be using up front? Well, there is. It's a way simpler offering. It's table storage. Table storage is again a simpler database than Cosmos DB. It's a column database, very similar to DynamoDB, very similar to Cassandra. So basically, we don't have that much, but if it fits our needs, it can be a really good pick. Okay, so what is the pricing for table storage? First, we pay for data, and we don't pay much. 7 cents per gigabyte per month. So not a significant value in a day for a day. The next part is that we are paying per 10,000 transactions. And here, use the word transaction very carefully. Those are not those transactions that we know from SQL Server. They are way simpler, especially since one of the protocols to communicate with table storage is HTTP. So don't expect that much. But if it suits your case, it can handle massive amounts of data. If you design your database properly to use index and so on, you will have really nice timings in milliseconds for big data sets. Okay, so are we done? We managed to fit our application data into a cloud-ready solution. Actually, no. There is an additional thing that in most cases developers and architects don't think about it. Traffic. Actually, output traffic. Why is it important? Simple reason. We are paying for it. almost 9 cents per gigabyte of outgoing traffic. In case of Amazon, it's full 9 cents, so in Azure we are a bit cheaper. Why is it a problem? Because of this. The average web page size is increasing. Currently, it's about 3.5 megabytes per website. This means that we'll use our 1 gigabyte frame at about below 300 requests. The case goes even worse if we look at about November of 2019, by very modest estimations, we'll hit 4 megabytes. So 256 requests. How to deal with it? How to deal with this? Quite simple. The way we always dealt with web performance. Use a CDN. And of course, Azure and every cloud provider is offering a CDN. Here, the price of output traffic is the same. This is the rule of all output traffic in any cloud provider. You always pay for the output traffic. Even if you are remoting, even you are doing simple operations, you pay for output traffic. Why? Because the cables, internet cables under the sea and connection is quite expensive. Sorry. But there is a plus. You get 5 gigabytes free. So, a small money saving. There is a different echo tip here. If we look at our website, we will see that most of this content is not ours. If it's not ours, then why should we pay for it? Actually, many companies, such like this one, are offering free CDN hosting for common libraries such as Angular, Bootstrap, and so on, so on, so on. Why? Because it speeds up web crawling for Google. That's easy. The benefit for us is that probably those scripts won't be loaded directly only for our website. It will load faster, and we won't be paying for this traffic. If Google is not an option, there is also always Cloudflare, a CDN that basically can be set up in just about 10 minutes, and it can lower traffic by 90-something%. I'm personally using it, and it's really awesome. It's free. Use it. As a bonus, it protects you from DDoS attacks, protects your DNSs, and so on, so on. Really, really good offering. Highly recommend. So this way, from 3.5, 4 megabytes, we are able to go down to about 12 kilobytes of HTML, because this part we will need to send actually. It's a standard size of HTML. And this means that we can do about 90,000 requests until we hit this 1 gigabyte. That's a lot. That's enough for us not to worry that much about it. So, are we done? Not exactly. Storage. We have to store our data somewhere. There's no way around it. So, what would be the simplest way? To use a drive that we connect to our VM, and that's all. To actually talk about storage, we need to talk about size of the storage. For simplification, let's say 1 terabyte data. This will boil down to about $40 a month and $1.3 a day. Is it much for a drive that is managed? I would say not that much. And we are also paying for transactions. Not that much. But can we do better? Let's try. Next offering, a bit more cloud-friendly offering, is Azure Files. It's basically managed SMB. The same protocol that you use to share resources between your computers on LAN networks and so on. It's basically, you can buy it, host it in Azure, and that's all. Why this not drives? Because it's way better way to store files, and you paths for SMB can be handled by default by system I/O. You don't have to change your code to actually for the application to work with SMB. Let's look at the pricing. 6 cents a gigabyte a month. So 1 terabyte, $60. Yeah, it's more expensive, $2 a day. Why? Because SMB is not a cloud-ready protocol. It was not designed for running in the cloud. Again, we are talking about the 80s, something like this. You still have to have a server that is provisioning. You can list files. You can do a lot of operations that are really time-consuming, resource-consuming, and so on. Basically, you can do everything that you can do with normal files. And of course, we also pay for transactions. But what if we rethink how we think about files and storage? Actually, the cloud, so let's simplify that. We are talking about the cloud in terms that AWS started with 2 offerings. One of those offerings was actually to store data, S3. In Azure, it's called Azure Blob Storage. So basically, we are storing blobs. The biggest difference between the previous offerings and this one is that this uses HTTP protocol. So yeah, system.io won't handle those paths. We have to change our application. There is no way around it. But if we spend those dollars on changing the application, what do we get in return? A quite significant price drop, about 2 cents for a gigabyte a month. This means for 1 terabyte we'll be paying below $20, so we are 60 cents a day. The price is 3 times lower for between SMB and 2 times lower between drives. What is also really nice is that here we can enable zero redundancy and so on, more advanced cloud-ready options. We don't have to think about it. And again, we are paying for operations, which is obvious for all of those services. So we are done. Again, not exactly. There is still one part that does not scale: Windows. The last time we said we are talking about our compute engines, where we will execute our application, we had really beefy machines. But why do we actually need such beefy machines? What's the reason? Actually, this is the reason. If we look at our architecture, the only place where we can execute business logic is on the IaaS server. There is no other compute. Okay, you can run as a SQL stored procedure, but let's be sane in here. I remember a couple of years ago, way more than I would be comfortable saying, I saw architecture of this company. It was way before any cloud buzzwords and so on. It looked like this. So you can believe me, it was some time ago because, yeah, this looks old. But the key feature here is on the top, the app server. Those are the servers that are serving HTTP requests. Look what they are connected to. To a master database, to a cache, and to a queue. The idea here is that those app servers are really stupid. And this is a compliment. They are not executing any application logic. They are only enqueuing logic that will be executed later by offline workers, but by workers which are not basically connected to this request. This architecture is really nice because we can have fast HTTP responses and we can scale the backend, the processing engines, totally independent, since it is based on queues. And this architecture has its counterpart in Azure, basically. Azure Cloud Services. Why I'm saying that it has a counterpart? Because it's in this offering, we define 2 different roles. One is a web role, the second is a worker role. As you can imagine, the first is serving HTTP request, and the second is basically a background worker communicating over a queue. Sounds familiar? Yeah, it should. So let's look at the pricing. The cheapest VM, because let's not kid ourselves, we are talking about the cheapest ones we can get, is a 1 CPU and almost 1 GB of RAM. It would cost us about $50 a day. That specification is not that much. If we beef it up a bit, we will get in the ballpark of $1.50 a day. Looks okay, but can we go better? Can we do better? Yes, app services, a bit more cloud-ready solution. Now, what is the main difference between the previous one and app services? Previous, we had access to the operating system. We could remote to the VM. In app services, we are deploying application via Git or FTP or different, even Dropbox, but we don't have access to the underlying operating system. This, for example, makes things way simpler for scaling and moving application and so on, but we are giving up some capabilities, and in return, we are getting some different benefits. So yeah, let's look at scaling. The cheapest one is a free offering, which is quite interesting because it offers us 60 minutes of a CPU a day. Now, this might sound a bit strange, but the idea is that those machines will be woken up to serve a request, and then they will be basically die down. So if we just have a website that is used by a couple of people and we only want it to basically run, that's awesome. We are not paying for it. So if it's free, it has to be good. The next offering, if we want to be have more uptime, is a D1 offering. Here we are getting free computing hours a day, and the price goes a bit up. If we want a proper, normal execution engine, we go to B1. We have 1 CPU, 2 GB of RAM, but the price goes to about $2 a day. Not ideal, I would say. Let's look at different offerings. Azure Kubernetes Server. So basically, we create Docker images, we give it a configuration and say, run it. And it's free, the offering. But the ideal how Kubernetes services is run, we have to provision on which VMs will it be running on. And for those VMs, we have to pay. The offering itself, it's free. So yeah, it's not ideal for us. Azure Service Fabric. Again, a similar use case. We are provisioning VMs. We are saying to the service, run it. The service itself is free, but we are paying for VMs. Not ideal, I would say. And now we are talking about functions. Because, let's be honest. Every talk about Azure has to talk about Azure functions. That's the world we are living in. Basically, we went from the ideal of give me a computing engine, an operating system. Then we went to basically execute a operating system. Then we went to execute a set of DLLs. And now we are saying execute this small piece of code. If we are scaling down the pieces of code that we want to run, this means that we are giving more elasticity for the cloud provider. And again, it applies to every cloud provider, elasticity, so the price goes way down. Okay, so how does the price go down? We are charged in Azure Functions in 2 ways. One is execution time, a second. The idea here is that if we have a single request, it does not have to be a web request, but it has to be a request. The trigger can be something happening in a Cosmos DB, something happening in a queue, and so on and so on. if we have a single request and it uses 1 gigabyte of memory and it runs for 1 second, we will be paying this much for it. Sorry, but there's too much zeros to actually say it out loud. On the plus side, we are getting 400,000 gigabyte a second free, which is in most cases more than enough, basically. And the second part of how we will be built is total executions. So how many times our function is being triggered. And we get 1 million free of them. And as a last tip, all those limits are being assigned per single Azure function instance. If we want, nobody is saying that we can't split our application into multiple instances and run different parts of the code on different instances. It will be a headache for development, but yeah, we can. But I don't recommend it. It's not a good idea. But there's a problem. And this graph shows what is the problem here. Those are cold start times. So the times that it takes for a function to be woken up. Because since we are conserving resources, the function by default is not running all the time. If a first request comes, it is going to be loaded, compiled, and basically executed next. The timings for C# and basically any compiled languages, this also applies to Java, are in the ballpark of 4.5 to 5 seconds. Imagine making a web request and waiting for the first 5 seconds. Not ideal. But if we go way in this direction, we will see that for some languages, the timings are really, really tiny, at about 7 milliseconds. Those are for Node and Python. If I would now go to my development team and say to them, we write our ERP system in Node, this will be probably the reaction I will see. But think about our architecture. Here we are talking about code, about how we will host our code for the app services. So the really stupid ones, the really tiny ones. Their only job is to get the data from database, map it, and send it to the queue. I will be more than happy to write it in Node. It's really tiny code base. We'll have all the benefits of Node without any problems of maintaining it. But now you should say, yeah, but where will we execute our really heavy C#, F# or Java code with the complex business logic? Here, in Azure Batch, or how they are called differently, low priority VMs. The idea behind this is simple. Each cloud provider has a lot of machines that are not being used. So here it's saying for us, you can have this machine, but if I need it, I will take it back from you. Sounds like a quite nice usage, but how much money will we save? Let's compare it. Let's take the 4 CPU, 8 GB of RAM machine. It normally costs us 23 cents an hour. If used as a batch, it will cost us about 10 cents an hour. Now you should say, but yeah. But we know already that we can buy VMs as reserved VMs. Let's compare the prices for reserved VMs. Here we have a more beefier machine, 4 CPUs, 16 gigabytes of RAM. In a 3-year pre-allocation, we would be paying 26 cents an hour. If we use it as a batch, we are paying about 15 cents. And now you might say, okay, but 15 cents is still way over our budget. If you think so, you are thinking it wrong, because Here, we are not saying about VMs that are running all the time. Why? Because they have 1 second accuracy for timing and for pricing. Those machines can be easily deployed, woken up by an Azure function that will check if there is enough messages for them to process. Remember that those machines don't affect user experience. They are not processing HTTP requests. They are taking things from the queue and doing background jobs. If you properly design your business workflow, most workflows can be implemented this way. So, we are done? Not exactly. If we split our application into multiple parts, we need for them to actually communicate between each other. Some way of communicating, preferably non-HTTP, because our receiver probably is down. We need queues. Since we need messages which are persistent, the most obvious choice is Service Bus. Service Bus has 3 tiers of pricing. One is the basic one. In basic one is the most limited. We only have queues, we don't have topics. So send to all is not implemented. We are paying for 1 million operations, 5 cents, not that much. And the other biggest drawback is that we don't have transactionality when getting data from the queue. But let's say that we want transactionality. We go to the standard layer, which has almost all the features, and we are paying $10 upfront per month. So yeah, we have to provision. But we are paying separately for usage, the same price for usage, and as a bonus we are getting 13 million operations gratis without any fee. The next quite nice thing is that our maximum message size is increased to 256 kilobytes from 64 in the basic layer. It looks quite good. But if it's still not enough, we can go to Premium. Yeah, Premium. Here, we are paying $22 a day. We have much better performance, and the message size is up to 1 megabyte, which I don't recommend, but basically, if you have such big messages, put it in a blob and send a link over. But yeah, you have premium Azure Service Bus. But there's a different way of doing it, a simpler and more cost-effective. Azure Queue Storage. It's a mechanism built upon Azure Table Storage. So the main difference is that it's way simpler. We don't have transactionality, the message is limited to 64 kilobytes, but the service can handle hundreds of gigabytes. If you are sending a lot of messages, Azure Service Bus may not be ideal. This is the solution, and it's way cheaper. For 1 gigabyte of data, we'll be paying about 5 cents a month. So not that much. And of course, we are paying per 10,000 operations. 1/4 of a cent. So again, negligible costs. So let's look how our solution now looks. We have a client. It talks to a CDN to get resources. It talks to a blob storage. You might say, why? Simple. Since blob storage is providing HTTP interface, it can serve files directly. We don't have to have a function just to serving files. We can just serve links to a blob storage. Nice. Saves us some code. Next, we have a function that will be sending messages to Azure Service Bus and will be writing data to table storage. Simple. And in the background, we have messages that wake up on Azure Functions, and if there is enough messages to actually process, we create additional Azure batch VMs. We are cost effective, and we are scalable, resilient, and all the benefits of running in the cloud. That's a lot of things to think about. And there's the amount of different services offering is increasing in really dramatic pace. Basically, Azure is being deployed each quarter. So yeah, and the pricing listing is quite a lot. And again, all those prices are changing dynamically. When I was updating those slides, most of them decreased by 20%. And for Cosmos, they went significantly down. But there is a really good point to actually learn all those things, investigate, because knowledge is money. And in case this knowledge is money in saving us time, saving us money that we would spend on the resources, and if we make a mistake and provision the wrong service, we will be paying a lot. It's not like on-prem that it will somehow work. No, our boss and our company will get a huge bill. So yeah, before you use, learn. And the last thing is, there is no such thing as a good, proper architecture. You can optimize either one of two things, either developer time and use more complex, more feature-proof functionalities, or you can spend this time on developer time, redesign your system, design it to be cloud ready. And again, here it goes. And this time, that's really all. Thank you very much. Any questions?
Yeah, we are talking about the different services costing under $1 amount. What would be the total cost?
The question was, what would be the total amount combined? Actually, I was designing, this talk came into my mind when I was designing my service. If I would not be using Elasticsearch, which is more pricier, the actual cost of running my service would be about $2. It strongly depends actually from the functions and redesigning and how much requests will it be used there, actually. So more or less, we are in the ballpark. Any other questions? No? Okay, thank you very much once again.